Hi, everybody. We're going to work today on measuring instantaneous voltages on the sine wave using our oscilloscope. And we're going to do that with multisim, and that's part of lab 1 at step 7. So let's go over to lab 1 for a sec, and we're going to see what it is we're talking about here. So we're going to set our function generator to 2 volts RMS at 1.25 kilohertz sine wave. Okay? And it wants us to adjust the horizontal position so it's at 500 microseconds. So I'll demonstrate that on the scope. Okay, so what we're going to do is we're going to set up that waveform, and then we're going to measure the instantaneous voltage at each of these points. Okay, at each of these points. So let's go over to multisim. All right. So here we are now. I've got my scope set up and my function generator. So the frequency, so we're on sine wave, good. Frequency is 1.25 kilohertz, 1,250 hertz. Then the amplitude is 5.656 volts peak to peak, which is 2.828 volts peak, which is 2 volts RMS. Okay, so we had to convert that, and I'll make sure that my offset is at 0. So we're on our wave here, and what it's asking us to do is it wants us to adjust our horizontal positioning. So this is at 500 microseconds. So we're set at 1 volt peak, 100 microseconds, sorry, 1 volt per division and 100 microseconds per division using our vertical and horizontal scale settings. Okay, volts per division, seconds per division. So I'm going to move the positioning. So it's going to go to the left, and it's going to be at 500 microseconds. Now, since this is 100 microseconds per division, this is the 0 point. Okay, so what we've done is we've moved it 500 microseconds to the left, so the wave will start exactly at 0. All right, so what I'm going to do here is I'm going to hit single sequence. So I only get one cycle of the wave. There we go. All right. So now, before we get started, we need to know what we're looking for here. So here we have a sine wave. It's 100 microseconds. It is 8 divisions long, which is 800 microseconds, which is the period of a 1.25 kilohertz wave. All right. So each of these divisions is 100 microseconds. And what we're looking to do is to measure the voltage at each of those times, the instantaneous voltage. We know that it's 2.828 volts peak, all right? But what is it here? What is it there? What's the voltage there? What's the voltage here? That is what we're going to figure out today. Instantaneous. So now, this is 800 microseconds. We know that at 0 microseconds and at 800 microseconds, our voltage is 0. And we also know halfway at 180 degrees that, or pi radians, that it's also 0. All right? Now, we also know that at 100, 200 microseconds, which is here, and at 600 microseconds, which is there, our voltage is going to be V peak, our instantaneous voltage. All right, so what is it in all the other spots? That's what we have to figure out. So let's go to some calculations here. All right. So we're here now. We have one iteration of the sine wave. So each of these are 8 divisions. So we have 0 microseconds, 100 microseconds, 200 microseconds, 300 microseconds, 400, 500, 600, 700, and 800. Okay, so that is our sine wave broken down. We know that here at 100 microseconds, our voltage is 0 volts. Okay? And we have 200 microseconds, 300, 400, 500. Okay, so that's what we have. All right, now, I made a little mistake here. At 0 microseconds, we are at 0 volts. Okay, now, what is it at 100? What is it at 200? So first thing we have to figure out is our angular velocity. We figured that out in step 2, and our angular velocity, which is in radians per second, is 2 pi f, okay? And that is equal to 2 times pi times 1250, we know frequency, is equal to 1.25 kilohertz, okay? So our angular velocity is 7,853.98 radians per second, okay? So because one cycle is 2 pi radians, okay? And we know that 2 pi radians happens 1,250 times a second. That is how we get this number, okay? That's how we get that number. If you want angular velocity in degrees, okay, then we would do 360 times frequency. Okay, but right now we're doing in radians. We're just going to stick with that. Okay, now our instantaneous voltage is equal to V peak times the sine of our angular velocity, omega t, which is our time. Okay, so whatever time we want to figure out, if we want to figure out the voltage here at 450 microseconds, we would do V peak times the sine of omega times 450 microseconds. Okay, so now in this wave, we know it was 2 volts RMS, which means that is equal to 2.828 volts peak, which is 5.656 volts peak to peak. All right, that's what we have there. So now, whenever we plug in whatever time we want to find the voltage at, we're going to say E is equal to V peak, which is 2.828 times the sine of 7853.98 times time. That is our formula. Okay. Now we have to make sure that our calculator is in radians mode. And the way we do that is we go mode and we hit mode several times and we make sure that we are in radians, which is 2. Okay. And your little square up here will change to an R. That's how you know you're in radians. So at 100 microseconds, at this point right here, 100 microseconds at this point of our wave, what is our voltage? And the way we figure that out is at 100 microseconds, so just do an example here, at 100 microseconds, okay, our instantaneous voltage is equal to 2.828 times the sine of 7853.98 times 100 microseconds. Okay, so we're going to get there. I'm going to do 2.828 times the sine of 7853.98 times 100 micro, and I get 1.99969, so I'm going to say 2 volts. Okay, 2 volts. So At 100 microseconds, it is 2.0 volts. We know at 200 microseconds, it's going to be V peak, which is the 2.828. We also know it's going to be negative 2.828 at 600 microseconds, negative 2.828 volts. Okay, at 400 microseconds, it's going to be 0. And at 800 microseconds, it's going to be 0. We know that. Okay, so what is it at 300 microseconds? So here it is 2.0 volts. Okay, there, 2.0 volts. Here it is 2.828 volts. So what is it at 300 microseconds? What is it at that point? Okay, so let's do the, we should know, because it's a sine wave and we are the same distance from the peak, 100 microseconds either way, it should come out to 2. But let's calculate it. At 300 microseconds, okay, E is equal to 2.828 times the sine of 7853.98 times 300 micro. So what does that equal? So let's go in our calculator. I'm just going to go back and edit that one, and it should come out the same, and it does. Okay. So we should know in this case that 500 microseconds and 700, remember this drawing is not to scale, should be the same, but negative 2.0 volts. And this is negative 2.828 volts. All right. So if we do 500 micro, we would say, I would come up here and I would edit this to 500 micro. Okay, and here I get negative 2. If I did 600 micro, I'm going to change that there. I get negative 2.828, so which is right there. So there's where we have all of our values. So 500 is negative 2.0 and negative 2.0. Okay, so that's what we get there. So how do we see that on a scope? These are our calculations. How do we see that on a scope? Okay, so we're going to switch over to multisim. There we go. So now I'm in multisim, okay? I have my function generator set, frequency 1.25, amplitude 5.656. There's no offset, and I am on a square wave. I'm going to start the simulation. Now, what we have is this. Now, it told us to move this over, which we did before, okay? And then we're going to hit single sequence, so we capture just one. So as I said before, we have our one wave, okay? Now, how do I measure that point right there? Okay, so there's a function on the scopes called a cursor. So it's right there. So we have two types of cursors. We have voltage cursors, which measure vertically, the distance between two vertical points, and we have time, which measures horizontally. So if we see our horizontal, that's what we have there. So let's go vertical, okay, because we need to measure voltage. So I have my two cursors here, okay? So what I'm going to do is, the way cursors work is they actually measure the distance between the two cursors. So I'm going to set my first cursor on 0. So what you have on the right on the scope is you have the position of cursor 1, which right now is negative 770 millivolts at 1 volt per division, and cursor 2, which is up here right now. Okay, so this will tell you the position of cursor 1, the position of cursor 2, and the delta between the two. This is what we're interested in. So let's set our reference to 0, which is the middle of the waves. Now I'm in 0. And now this is where the scope, this is where the sine wave crosses 100 microseconds. So let's move cursor 2 to that point. Okay. There. So cursor 2 right now is at 2.04. So that is our delta between the two cursors right now. So that is our voltage measured at 100 microseconds. It's also crossing here as well, right? So we can use that for 100 and for 300. Now for 200, 100, 200, which is this point, we can move our cursor up. Okay, this is kind of eyeballing a little bit. There, and I'm at 2.81. All right, so now if I want to do here, if I want to do, say 700 microseconds, so this is 700, and this is where it crosses, I will move cursor 2. Now watch what happens to delta. Delta is now negative. So I'm there, so I'm at delta 2, negative 2 volts, which is what we calculated. All right. Now, when you get better with the scope, so this is how you use the cursors, okay? When you get better with the scope, what you're looking to do is you can actually, this is 100 microseconds per division. But if I spread this out, okay, if I spread it out, I can still get readings. So now it's 50 microseconds per division. So right now, my cursor is where the sine wave is crossing the 50 microsecond line. So what's the voltage at 50 microseconds? So I'll just use my formula and I'll calculate my voltage for 50 microseconds. So it's 2.828 times the sine of 7853.98 times 50 micro. So I calculated 1.08 volts, okay, at that point. So now I got 1.06. So I have 1.06, so it's pretty good. It's pretty good indeed. All right. Now, the other place you can use this is if we do time, because you're going to have to measure the time difference between waves when you're doing phase shift, is now I can put one cursor in one place, put the other cursor in another place, and I can measure the time difference between the two. So right now the time difference between these two cursor lines is 192 microseconds. Okay, cursor 1 is at 150, cursor 2 is at 342. So 192 difference. If I change my time base, okay, the cursors will move with them and keep the same delta. All right, so that's something you could play with on your own. But that's just a way to measure instantaneous voltage, how to calculate it, and how to measure it and see it on your scope. All right. So if you have any questions, again, on the discussion board, and away we go. Have a great day.